Hi guys, a very good evening everyone. Welcome to the session and welcome to Om Institute. And yes guys, now in this GATE and ESC concept booster session, yes, you are all preparing for GATE ESC 2025 or 26 or maybe upcoming years. And there comes a topic which is always producing questions. Okay, sometimes in the engineering maths part, sometimes in the general aptitude part, and of course it is a topic which disturbs, if not all, but disturbs many of the students, as yes, that is nothing other than probability. And that is the reason in this concept booster session I thought, let us conquer this probability, let us become master in this probability, okay, by understanding different variety of concepts and questions of probability. Okay, and that's why I'm going to cover it in different parts. As you're able to see, this is part number 1. Okay, I'm going to elaborate my plan as well so that you can all understand. Okay, so quickly confirm me if the audio video is fine at your end. Audio is there, Sandeep, just a second. A slight noise is there, just a second. Let me check now. Hello guys. Yes guys, very good evening everyone. Okay, also others also quickly keep confirming me the audio. Let me check now. Hello guys. Yes guys, very good evening everyone. Okay, also yeah. Yes, I think looks better. In case of any issue, please do let me know. Yes, good evening Rohit. Definitely will make this topic easy and interesting. Okay. Okay, let me just check it once again. Clear? Yes. Okay. Chalo, yeah. So in case of any issue, do let me know. As of now, I think it's clear. Now it's fine. Cool. Okay. So now students are able to feel that it is fine. The voice is clear. So let's get moving ahead then comfortably. Okay, dear. So yeah, this is a brief intro. In case somebody new to my session, you can go through it. All right, now guys, this is what my plan is. Let me elaborate the plan. Okay, how to make this topic probability. See, I'm touching first of all probability. Later on, we will touch distributions also, probability distributions. First, let us be very clear with the probability. Okay, let's be strong in the probability. Then let's touch the different distributions and random variables. Okay, so today we'll take up the concepts and questions which are related with counting and Venn diagram. And let me tell you, probability is all about handling different variety of questions. Okay, so my of course approach will be taking enough variety of questions so that you understand each and every type of concept that can be linked with this chapter. Okay, so let's make it more question based and learn concepts from it. Okay, because if you talk about formula, there is only one formula. What is probability of any event? Favorable by total. But that simple formula can produce n number of questions. Okay, then next. Okay, Wednesday we'll have it, Monday, Wednesday, Friday. Then Wednesday we'll move towards questions comprising of dice, lot of variety of questions of dice. Okay, questions on cards and miscellaneous questions, the miscellaneous puzzle based questions related with probability. What are those miscellaneous questions? I'll take you in the next class. Then we move towards, conditional probability concept. Okay, and then the very important Bayes theorem. Okay, out of this, Bayes theorem is actually very important. Questions on dice is very important, and questions based on the basic counting are very important for all of you, right? These are the areas commonly producing a lot of questions. But yeah, of course, to go to Bayes theorem, you should have the clear understanding of what conditional probability is. Okay, so this is how I have planned the events. Let's get moving ahead. And as I told you, today we will have it. Okay, the counting and Venn diagram based in the part number 1, the counting and the Venn diagram based. Okay, so let's understand, some fundamentals through a question. Okay, the probability of occurrence of two events A and B are 0.4 and 0.7 respectively. They occur simultaneously with the probability 0.3. Okay, now find the probability that At least one of them occurs, only A occurs, exactly one of A or B occurs, at most one of A or B occurs, none of A or B occurs. Okay, so see, different variety of languages I have made on a single question. Okay, very good evening, Ramji. Okay, different variety of questions made on a single particular data given to me, that there are two events having the probability 0.4 and 0.7. Okay, and they occur simultaneously. Okay, simultaneously means together. Okay, simultaneously means A and B together. Okay, so what is this data? First of all, see, I am telling you the probability of occurrence of two events A and B given. So what is the probability of A? 0.4. What is the probability of B? Is 0.7. Okay. Then they occur simultaneously, that is together. Together means, okay, they are happening together means intersection, P of A intersection B, and that is given to be 0.3. This is given to you as 0.3. So this is the important data, first of all, that I have extracted from this given information. Right, dear? Okay, now find the probability that at least one of them occurs. Okay, at least one of them. Now what is this condition? At least one. At least one means either A should happen, okay, or B should happen, or even both. I'm not telling one of them should occur, at least one of them should happen. Okay, so either A should occur or B should occur, or what is the next case? Both. Now to make you explain, okay, how to solve this at least one, yeah, you know, exactly one, all of this case. See, in one of the event I say that probability of A is 0.4, then I'm asking what is the probability of only A? What is the difference between A occurs and only A occurs? There is a clear difference in the language also, you can see. Probability A occurs, probability only A occurs. So let us understand all of this by taking some specific Venn diagrams. Okay, like at least one of the A or B occurs. That's what I'm telling you. At least one of them occurs, either A or B or both. At least one. I don't say exactly one. That is the next case, number third, exactly one occurs. I'm telling at least one, to A or B or more than one, like both also can occur. Okay, so if I have to show it in the Venn diagram, okay, first of all, in this Venn diagram, this rectangular box will represent the omega for me. Here, omega for me is the sample space. Okay, list of all possible outcomes. List of all possible outcomes. Out of everything, there are only two events given to me, that is A and B. Okay, their probability 0.4 and 0.7 given to me. Okay, now I want at least one of them. So either A can happen or B can happen or both. Even this can happen. Okay, so like maybe only A or only B or both can happen. This is what it is, at least A or B. Okay, so now from this particular Venn diagram, what can I read as the formula? So dear, what should be the formula for A union B? Now, the probability that at least one of the A or B occurs, I'll again write down this language. Okay, at least A or B occurs. That means A or B or both. Collection of the elements from A or B or both is also known as the union between A and B. Okay, collection of all the elements from the set A and B in the set, we also call it as A union B. Now here we are interested in probability of A union B, and what is that probability of A union B? Okay, so now see, okay, I can take up the probability of A, then I can take up the probability of B. Okay, so is it equal to PA plus PB? See, if you add the probability of A and B, so what is going to happen? If you just add the probability of A and B, so what is going to happen? This portion, which I am calling it as both, which I am calling it as intersection. When I told A and B both occurs, A and B together occur, that is known as A intersection B, the common, the overlapping portion between them when both of them occurs. Okay, so when I am adding the probability of A and when I am adding the probability of B, so this intersection is getting added twice, it is coming with both. Okay, whereas I want probability of this portion and this portion and this portion, each of them to be counted only one time. So what I'm supposed to do, this common portion coming with A also, coming with B also, that means it has come twice. I want to make it come only one time, at least one time. Okay, so the extra one time, that is A intersection B, will be removed, and that is the very basic formula you must know. P of A union B, that is a very basic formula. Okay, that is P of A union B is PA plus PB minus PA intersection B, not only for this question but for other places also. This one is important. Okay, so as of now, what's going to be the answer? As of now, my answer is going to be P of A union B, and that will be PA, that is given to me as 0.4, PB is 0.7 minus intersection probability 0.3, and dear, this turns out to be 0.8, and this is what is the answer to the question number 1. Correct? This is what is the answer to the question number 1. Okay, now we'll take the next one. What is the probability that only A occurs? What is the probability that only A occurs? Now I told you probability A occurs is 0.4. Now when I say probability A occurs, see, understand this language. Okay, let's come here. When I say A occurs, what is the difference between A occurs and only A occurs? When I say A occurs, I'm not talking about B. B may occur, B may not occur. Okay, A occurs, so B may or may not occur. I don't care about B. That means this event B goes in don't care condition. When I say A occurs, simple, na? I am only bothered about A. I am only interested about A. Okay, but when I say only A occurs, this itself makes it clear. This itself makes it clear that B does not occur. Because question says that only A will come. Okay, nothing other than A. That means B cannot come. So I hope the language is clear to you. Okay, so when I say A occurs, okay, when I say A occurs, how the Venn diagram should look like? Okay, if this is my sample space, when I say A occurs, okay, let me again draw the two circles. Okay, one is for A, one is for B. And when I say A occurs, okay, this is what is A occurs. Okay, A occurs, B may not occur, or A occurs, B also may occur. Okay, so both this portion will come. So this is what is the Venn diagram for A occurs. Okay, the complete circle of A. Hope you are able to get it. But when I say only A occurs, that means I will only take the portion which belongs to A and I will not enter this portion because here A is there, but B is also there. But when I say only A, B should not come. Okay, so B should not come. So this has to be excluded here. That is the difference. If you talk about Venn diagram, that is the difference, right? Okay, that is the difference. Okay, so hope that is clear to all of you. But when I say only A occurs, that means... Okay, so what is the formulation now? So when I say probability only A occurs, okay, this is also known as, see, A occurs also means that B should not occur. Okay, A should happen and is represented by what? Intersection, as I told you. Okay, together. So A and means intersection, and B should not occur. Okay, I will call it as B complement. Okay, B occurs is B, B does not occur is B complement. B complement is the case when B does not occur, right? When B does not occur. So I can call it as only A occurs. That means A occurs and B does not occurs. And what is the simple formula for it? See, the simple formula is take the total probability of P, take the total probability of A, out of which subtract this common portion. Out of which subtract this common portion. This common portion, of course, is known as the intersection. And hence this is the formula for you. Okay, P of A minus P of A intersection B. Okay, P of A minus P of A intersection B. Okay, so here what is going to be the answer? So no need to remember every formula. See, previous one is important and very repeatedly used, so I have made it as formula. Others you can solve logically. Okay, or you can make the Venn diagram instantaneously. Okay, no need to, don't make probability a formula based chapter. Okay, make it a logic based chapter. And the logic here, such question is Venn diagram. Then there are different variety of questions we will see throughout this. I'm telling you multiple parts we have. Today is only the part number 1. Okay, so now what is PA given to me? 0.4. And what is P of A intersection B? 0.3. Okay, so when I subtract that, I get the probability of only A, that is 0.1. Okay. Now, third case, exactly one of A or B occurs. Exactly one of A or B occurs. Okay, exactly one, not more than one this time. See, when I told at least one of them occurs, so A or B or both. Okay, but here, A, if A occurs, B should not occur. That means only A. Or if B occurs, A should not occur. That means only B. Okay, so A is there or B is there, both cannot be there. Both cannot be there. Right? Okay, so A, B not occur. Okay, or if B occurs, A does not occur. Common nahi hona chahiye. That means I will explain you this once again by a very simple Venn diagram. Have a look into it. Exactly one of A or B occurs. Okay, so that's what I'm telling you. See, that is what I have been telling you. Okay, only A, exactly one should occur. If A occurs, B should not come. Okay, or only B. If B is there, again A should not come. That means anyhow common portion should not come. Okay, so what should be the formula? Okay, what should be the formula? Okay, what should be the formula? The formula is simple. Let us write down the formula here. Okay, so guys, even if I shade this portion, even if I take both, then it becomes A or B or both. That is A union B. That is A union B. Okay, so I can take the probability of A union B. Okay, but out of that, I don't want this common portion. Okay, so out of which I subtract A intersection B. Okay, or this can also be written as This can also be written as, what is P of A union B? PA plus PB minus P of A intersection B. Okay, so PA plus PB minus P of A intersection B, again P of A intersection B, so total 2P of A intersection B. This can also be written. But again, I'm telling you, don't make it formula based. Okay, just make it logic based, solve by Venn diagram, and hence what is my answer? Okay, so P of A union B, first question answer 0.8. 0.8. Second question answer, intersection. So intersection to given data hai 0.3, and hence the answer here is total 0.5. Hence the answer here is total of 0.5, right? P of A intersection B, again P of A intersection. Yeah, I am also continuously monitoring the voice. In case of any issue, you can also let me know, but hope it is now fine, continuously fine only. Next one, number 4. Okay, at most one of A or B occurs. Now see, at least one, exactly one, at most one. See, 3 different languages, and you have to be clear. Sometimes students are confused by this language only in the exam. Okay, now I have given you one question, only A occurs. Okay, similarly, you can solve one homework, okay, with respect to this. Same question can be there for B also, na? So one homework I have added, like only A occurs, you have understood. Similarly, you can solve only B occurs, very similar. Okay, from the B, subtract the intersection, you get the answer, simple, close. Okay, now come to at most one of A or B occurs. At most one. Now, what will this at most one of A or B occurs? Okay, what will be this at most one or B, A or B occurs? That is A or B or see, at least means what? A or B or both. More than one can also happen. Exactly one means what? When we were in exactly ones, it is A or B. Okay, exactly one of them. Okay, not more than one, not less than one. Okay. Okay, A or B. Okay, but not both. That was the condition. Here, at most one should occur. Maximum one of them should occur. Okay, or 0 can also occur. I'm telling you, the maximum one should occur. Okay, so A can occur or B can occur or none of them occurs. Okay, so see, if none of them occurs, how many events occurred? 0. So I'm telling you how many events should occur. At most one event should occur. How many events should occur, dear? At most one. At most one means if 1 is the maximum number, below it 0 can also come. Maximum one event can happen. So 0 is also possible. Na? Okay, you can take up to maximum one event. So 0 event or 1 event. 0 means none of them and 1 event means which one event? A or B. Both can be considered. So that is what is at most one of A or B occurs. Okay, now let's write down its formula. Again, not to remember the formula, but to write it by the logic by Venn diagram. You can also try simultaneously. What can be the Venn diagram? You have to be in A or B or none. Okay, but not both. Both means 2 events should occur, but maximum one should occur. Maximum one should occur. So see, let's go to this 4th Venn diagram. This is what is here. Okay, so here in this portion, none of the event is occurring. Na? In this portion, how many events occur? 0. Here only A occurs, so that is 1 event. Here only B occurs, so that is also 1 event. Here both occur. Okay, that means 2 events, and I don't want 2. I want at most, I want maximum 1 event to occur. Clear? I want maximum to maximum 1 event to occur. Okay, so I have to exclude this. Okay, rest all. 1 event can be there, 0 event can be there. 2 has to be discarded. This 2 has to be discarded. Okay, ji. This 2 has to be discarded. Done. Okay. So what is the formula then? What is the formula? Out of the total sample space, out of the total sample space, okay, that is the probability of sample space, which is always 1. Omega, as I told you, sample space. You have to just subtract. You have to just subtract this intersection. Okay, this intersection, A intersection B. That means it is 1 minus P of A intersection B. 1 minus P of A intersection B. Okay, so what is the answer? Okay, what is the answer? Okay, so 1 minus A intersection B, that is 0.3. So answer here is 0.7. Answer here is 0.7. And the last one here, none of A or B occurs. So see, A or B or none. Okay, out of this specific case, none of them should occur. I have separated this as a next question. None of A or B occurs. So that means only the portion outside A and B. Outside A also, outside B also. You should not take anything inside. Okay, so this is a simple Venn diagram. Let me show you directly. This one here. Okay, see, none of A or B occurs. So here, none of them occurs. Okay, here A occurs, so I don't take. Here B occurs, so I don't take. Here both of them occur, so I don't take. I only take the portion which is outside A and B completely. so that none of A or B should occurs. Okay, so what is the formula? Very clearly, what is the formula? The formula here very clearly, dear, is take the total probability, that is always 1, probability of sample space, because this entire box is my sample space. Okay, out of this sample space I need to subtract what? Out of this sample space, okay, you need to subtract what? See, you need to subtract this portion, na? Okay, and what was this portion equivalent to? Let me shade it once again. What was this portion equivalent to? This portion was equivalent to the A union B, the first case. Okay, that means out of the total sample space, okay, you need to subtract the A union B, and the probability of total sample space is 1. So 1 minus P of A union B has to be done. Okay, 1 minus P of A union B. Right, and now what is P of A union B? P of A union B is like the first question answer, which was 0.3, I think. 0.8, sorry. First question answer 0.8, 1 minus 0.8, so this answer is 0.2. Now see here, we can also make a property. See, none of A or B occurs. Okay, none of A or B occurs. None of A or B occurs. We can also make it as property. See, none of A or B occurs means, understand this language. This language also means that A also does not occur, B also does not occur. Okay, A also does not occur, B also does not occur. A does not occur is A complement, sorry. Okay, B should not occur is known as B complement. I am telling you A and B both should not occur. That means I want together both of them, and when I want both of them together, when I want common, it is the intersection. So what I am looking for is intersection of A complement and B complement. Intersection means what? Okay, A also should not happen and B also should not happen. That means none of them happened. Okay, so these can be written separately actually. Let me write down here. See, like this. Okay, and what is the formula? Okay, it has turned out to be 1 minus P of A union B. Actually, if I write it in the set form, first of all, A union B whole complement will be A complement intersection B complement, and similarly A intersection B whole complement will be known as the A complement union B complement. I am writing this in the probability point of view. These are something known as De Morgan's law. In set theory, these are De Morgan's law. Okay, A union B whole complement is A complement intersection B complement, so that when I want to write down probability of A union B whole complement should be equal to probability of A complement intersection B complement. Now, probability of A union B whole complement is what? Okay, see, if I simply ask you, what is the probability of A complement? 1 minus probability of A, na? Simply 1 minus probability of A. Either A will happen or A will not happen. Okay, either A will happen or A will not happen. Understand this very simply. Okay, let me take only one event. This is my sample space and this is only one event A, which can happen with probability PA. It does not happen means I'm outside. Okay, so I can be inside A or I can be outside A. Okay, this plus this makes the sample space, and what is the probability of the entire sample space is always 1. So I can always write down probability A complement is 1 minus PA. Okay, similarly probability of A union B whole complement is 1 minus P of A union B, and that is equal to P of AC intersection BC. This is what is coming up from De Morgan's law. Same thing, see. Okay, this is probability of AC intersection BC equal to 1 minus P of A union B. Okay, see, 1 minus P of A union B. But again, firstly I have solved the question by Venn diagram. I don't want you to remember any formulas. Okay, otherwise I could have told you this is De Morgan's law and solve. No, that becomes formula based approach, property based approach. No, we have to be logical, and if we are able to be logical, we will be able to handle more variety of question, because from probability any variety of question can come up to you, na? So that is why we have to be logical, not formula based. Hope that is clear to you. Okay, hope that is clear to you. Okay, similarly this next one. Okay, so again I can use the probability here. Probability of A intersection B whole complement will be probability of AC union BC, and again probability of A union B whole complement should be 1 minus probability of A union B, and this is what is probability of AC union with the BC. AC union with the BC. That's how it is, right? Okay. Chalo. Okay. Now also one more very important point from here. Okay, probability of none of the events occurring is 1 minus P of A union B. And what is P of A union B? A union B is also known as at least. The first case I told you, at least one of A or B occurs, is known as A union B. Okay, that means probability of none is 1 minus probability of at least 1. Okay, let me write it in a reverse way. Let me take one more slide here, and this is going to be important for some upcoming questions. Let me write it here separately, dear. Probability of at least one event is equal to 1 minus probability of none. Okay, is equal to 1 minus probability of none. Probability of at least one event occurring should be 1 minus probability of none of the event occurring. It's a very simple case, like probability A union B is 1 minus probability none. That's what I have told you here. Probability of none is 1 minus probability of union. Union is at least. Okay, so that's what we have deduced here also. Probability none is equal to 1 minus probability A union B, and A union B is known as at least one of the events occurring. Okay, so that's what I'm generalizing in the reverse way. Probability of at least one is 1 minus probability of none of the events. Looks simple but very useful for later discussions. Okay, it will be very useful. Okay, it will be very useful. Okay, chalo. Now, based on the calculations we have learned, let's take up a question. Okay, there are two events A and B. Okay, for which probability of A dash is again A complement. Different ways to represent A complement. We also write it as A dash, also known as A prime. Yes. Let's see. So, what is this, dear? Probability of A dash intersection B. What does it mean? A should not happen. Intersection means and. Okay, and B should happen. Okay, and B should happen. Okay, this means what? This means B and not A. That is what it means, no? This is not A, this is and this is B. Okay, that means only B. That's what is the case known as only B. That's what is the case known as only B. Clear? So that means first statement, okay, P of A dash intersection B means probability of only B is 0.22. And now how do you write down probability of only B? Okay, take the total probability of B and subtract the common, because I only want B to occur, A should not occur. Okay, so common I have to subtract, just like I explained you. This is 0.22. Okay, say this is equation number 1. Okay, let's see what we can extract from here. Next is A dash union B dash. Just now we learned about this. Okay, what is this now? The next condition coming up is probability of A dash, okay, intersection, sorry, not union, intersection B dash. Okay, intersection B dash. So what is that? Tell me what is that? Okay, A dash, not A. B dash means not B. Intersection means and. Okay, neither not A and not B. None of them should occur. It basically means what? None. Okay, what I am telling you, A should also not occur, B should also not occur. Okay, both should not occur, and is there. So that means none of the event occurs. Okay, none of the event occurs. Okay, and that is given by 1 minus probability of A union B. Just now we learned that. Okay, that means this fourth one put in the form of data. Okay, this is equal to 1 minus probability of A union B, and that should be 0.18. Or I can say that probability of A union B is 0.82. Probability A union B is 0.82, and hence I have the second question answer. Hence I have the second question answer directly. P of A union B is 0.82. I want the P of A also. Can I do it from here? Can I do it from here? Yes, why not? Let's do it from here. What is probability of A union B? Let's expand this formula. Is given by PA plus PB minus P of A intersection B. Okay, and that is 0.82. Okay, now PB minus P of A intersection B. This is 0.22 as per the first equation. This part, okay, this much of the part, okay, it is equation number 1. So I can write down PA plus what is the result of equation number 1? 0.22. PA plus 0.22 is 0.82, and what is the value of the PA? It should be 0.6 then. It should be the 0.6. That's it. So hence we have our answers. Okay, hence we have our answer. This goes as 0.6 and this goes as 0.82. Simple na? Simple enough? Okay, all these basic approaches should be clear. All these basic approaches should be clear, right? Any confusions, any doubts, please keep asking me. Okay. Okay, any basic confusions, any basic doubts, please keep asking me. Okay. All right. Chalo. Now, why don't we take a 3 Venn diagram case? Why only 2? Because I am dealing with Venn diagram, I can go up to the 3 Venn diagram extent also. Now, in the 3 Venn diagram, okay, see, let us first generally study this 3 Venn diagram. Okay, there are see, again, this is my sample space, the entire rectangular box, which contains 3 events, A, B, C, given to you. Okay, then you need to understand, like, when again you are in this particular portion, see, when you are in this particular portion, you are representing the portion which is belonging only to A, but not B and not C. That means only A. Okay, this means only A. Set A but not B, not C. Everything is written, you can read later. Okay, but yeah, let's understand by the logic that we have developed in the previous question. Similarly, when I talk about this portion, only this much of the portion. So this is the portion common to A and B, but not C. Okay, but not C. But when I take it like this means common to A and B, C can also come. Okay, C can also come. Okay, so that is the difference. If I take this much, A and B common, C also coming, but if I take only this much, okay, A and B, but not C, that becomes not C. Similarly, rest of the things are understood, especially when I take this much. So this is the case where all 3 are occurring, and that is A and B and C, all 3. Okay. So you should be able to read this, okay, Venn diagram. Now, let us understand this question, okay, to be applied on to that Venn diagram. Here it is. Okay, the probabilities that a student passes in mathematics, physics and chemistry. So there are 3 events: passing in maths, passing in physics, passing in chemistry, and the probabilities are M, P and C respectively. Okay, out of this, okay, out of these subjects, the student has 75% chance of passing in at least one. 75% chance of passing in at least one. Okay, 50% chance in passing at least 2. Okay, next data is 50% chance in passing at least 2. Okay, and a 40% chance of passing in exactly 2. Okay, now choose the correct option. Choose the correct option. This is a MSQ question. MSQ has gone at the top. I'll write it here. This is a MSQ question. Okay, so one or more than one choice can also be correct here. Okay, one or more than one choice can be correct here. Okay, so guys, 40% chance of passing in exactly 2. Chalo, let's start solving now. Okay, see, first there are 3 events. Na? First of all, there are 3 events. Na? So let me make this simple Venn diagram. Let's only take the circles. Okay, that is belonging to A, B, C. Okay, or we can call it as maths, physics and chemistry. Okay, A, B, C. Okay, A belonging to maths, B belonging to physics, C belonging to chemistry. Okay, now as I told you, there are several portions. Like when I am here, okay, that means I am only in A but not B, not C. Okay, let us say the probability of this portion is A. This portion, A and B but not C, B. Okay, this portion probability is C. Okay, then D. Okay, yeah, maybe if you are confused by letters because C I have used here also, so let me use some different letters. Suppose this is P, Q, R, okay, S, T, U, V. Okay, so see, what is T? Especially what is this T? T is the probability when all the 3 events will occur. Okay, when all the 3 events will occur. Okay, because that is the region common to all 3. That is the region common to all 3. Okay, now come here. Okay, now come here. Okay, 75% chance of passing in at least one. What is the first statement? 75% chance of passing in at least one. Okay, let us understand this in equation. Okay, first event is probability of passing in at least one. 75%. Okay, so at least one means 1 or 2 or 3 subjects. Okay, at least one event should occur, at least one of them. So when I am in, what is this probability P? Okay, what is this probability P? P means you have passed only in maths. Q means you have passed in maths and physics both. T means maths, physics, chemistry all. So here what you have to consider, you have passed in maybe only one subject or maybe 2 subjects, or maybe 3 also. That means all of them. P also will come, Q will come, you have passed in 2 subjects. R, only physics will come. S, maths and chemistry will come. T, maths, physics, chemistry, all 3 will come. U, physics and chemistry, that will also come. And V, only chemistry, that will also come. The sum of all of them is 75%, that is 0.75. That is 0.75. Sum of all of them is 0.75. Okay. Now, second statement, probably 50% chance of passing in at least 2. There is a 50% chance of passing in at least 2. Let us write down this separately. Probability of passing in at least 2. At least 2 is 50%. Okay, at least 2. That means 2 or more. 2 or more. So what are the events that can come up here? Q, okay, passing in 2 events, then S, and then U, and then T separately. Okay, P, S, Q. 2 events, T passing in 3. So at least 2 or more. Okay, so this is 0.5. And third event, the probability of passing in exactly 2. The 40% chance of passing in exactly 2. Okay, so as we have already noted the difference between at least and exactly, here I am going to talk about exactly 2. Passing in exactly 2, probability 40%. So when I want to write exactly 2, Q will come, S will come, U will come, but not T. T means passing in 3. Here I want only passing in 2, exactly 2, not more than 2. Previous case was at least 2, so 2 or more is allowed. But here exactly 2, not more than 2, not less than 2. So this is 0.4. So dear, okay, if I call it as equation number 1, 2, 3 respectively, and very clearly when you subtract second and third, very clearly when you subtract the second and third, you get a data here. Okay, because QSU, this is common. Okay, you will only get T, and that will be 0.5 minus 0.4, and that is 0.1. Okay, 0.1. Okay, now question is talking about P plus M plus C and P into M into C, into intersection. They are also talking about intersection, and T is what? Common to all. T means, okay, T is the case when a student has passed in all 3. Okay, all 3 means maths as well as physics as well as chemistry. Okay, that means representing it by letter M, P and C. Okay, this is 0.1, correct. Okay, the product of them is 0.1 because the intersection comes up, events happening together comes up with the product. Okay, intersection comes up with the product. Okay, that is what it is. So M into P into C is 1 by 10. Yeah, 0.1 is 1 by 10. So at least this is correct. Okay, now P plus M plus C. Okay, P plus M plus C. So when I want to add, dear, okay, P plus M plus C. Okay, now see please. What is P? Okay, P here means physics. Okay, P here means physics. See, this P is for physics actually. This M is for maths. And this C is for chemistry. So physics. Okay, what are the portions included in physics? Q, R, T, U. Okay, Q, R, T, U. Separated. Then maths. P, Q, S, T. P, Q, S, T. And chemistry, what are the probabilities? When I say passing in chemistry, it means everything to be coming up, na? Okay, see, that is why I will add. When I say probability of passing in chemistry, so maybe only chemistry, or chemistry and physics also okay, chemistry and maths also okay, chemistry, physics, maths also okay. When you take any of the portion from here, that means you have passed in chemistry. Whatever others, I don't care. That is what now, when I say probability of chemistry, so only chemistry, others also possible. I don't care about others. Like I told you, don't care about B earlier. Okay, so yahan pe what will come? STUV. Okay, STUV. Okay, this is to be found. Okay, now let's try to find it. Now, how many times the letters are coming? See, P is coming. Okay, I have used P once. Okay, then Q. Okay, R, S, T. Okay, U is here, and V is here. Okay, these are definitely coming one time. Okay, plus now what are the others? What are the others? Okay, then there is a T coming, and then Q. Okay, Q and S. See, now this is this. This is Q and S and U. Q, S and U. This is also coming up, and T additionally coming up 2 more times. So 2T. Additionally 2 more times. Now do I know this value? This is equation number 1. Sum of all P, Q, R, S, T, U, V. P, Q, R, S, T, U, V. As per equation number 1, 0.75. This is equation number 1. Q, S, U. This is equation number third. Okay, this is equation number third. So let's put down, this was 0.75. Okay, this is equation third 0.4 and plus 2t, and t already found as 0.1. Okay, so let's add it. Okay, 0.6, 0.75, 1.35. 1.35, which is also 27 by 20. Okay, and hence option number A. Okay, so to this MSQ question, option number A as well as C. MSQ, multiple select question, one or more than one can be correct. So here two choices are correct. This is a good question, okay, based on 3 Venn diagram. 2 Venn diagram also we understood, that is also very much expected, little bit simpler. 3 Venn diagram, little bit better question. Okay, so this is option number A and C. Okay, let's move ahead to the next question then. Any doubts, please keep asking me honestly. Okay, now some counting based, and the very simple question, that first we'll pick up to understand this counting nature question is the bag and ball. Very simple, very fundamental, and I will divide it into 3 different cases. Okay, a bag contains 6 black and 4 blue balls. 2 balls are drawn at random from this bag. What is the probability that both the balls will be blue? Okay, both the balls will be blue if the balls are drawn now one by one with replacement, one by one without replacement, and then 2 at a time. A bag contains 6 black and 4 blue balls, and how many balls are drawn? 2 balls are drawn. Okay, so what is there inside the bag? 6 black, 6 black, 4 blue. Okay, 6 black and 4 blue. Okay, that means total 10. That means total 10. Now come to the first question. What is the probability that both the balls will be blue if the balls are drawn one by one with replacement? One by one with replacement. Okay, balls are drawn now one by one, but with replacement. Okay, let us solve it very simply. See guys, what is going to be the answer? Forget one by one. Just imagine that you have drawn only one ball. Just imagine that you draw only one ball. What is the probability that the ball is blue? I want blue, na? You draw one ball. What is the probability that ball will be blue? So simple, favorable by total. Okay, so how many blue balls are there? 4. And how many total balls are there? 10. Okay. So see, let me split it for you. Let me make it easy for you before I write down the answer. So see, first answer that I have written is 4 by 10 into something. Okay, so see, what I want probability both blue. Okay, that means I want probability first blue, both blue, na? So I want first blue and also second blue. I want the probability of first blue and also the second blue. Okay, now what is the probability first blue? Okay, 4 by 10. Okay, and means I'll multiply. Intersection, I'll multiply here. Second blue. Now see, second blue, one by one with replacement. Okay, so whatever is the first ball, you noted, maybe it is blue or not. Okay, you took the first ball, but you replaced it back. You replaced it back into the bag. Now because it is replaced back into the bag, what is there in the bag? Again 6 black and 4 blue. So what is the probability of again getting blue? What is the probability of again getting blue? Same 4 by 10. Okay, same 4 by 10, and then answer is 16 by 100 or 0.16. 0.16. Hope the first answer is clear to you. Okay. Oh, good to know, Praveen. Congratulations, you have got seat in IIT Kharagpur, and that too VLSI seat. So you will definitely be getting good placements also. VLSI in any of the top IITs. It's very good, very good. Congratulations, Praveen. Very happy. God bless you. Okay. Right guys, so this is what it is done. Okay, let's move ahead to the second. Now, second, one by one, again one by one, but without replacement. One by one without replacement. Okay, second is solve again one by one, but without replacement. One by one without replacement. How to do this? One by one without replacement. Okay, let's do it. Okay, so once again dear, I want probability both blue. Question is same. What is the probability that both the balls will be blue if the balls are drawn one by one without replacement? Both the balls blue means, again, let me make it simple by splitting it. First blue and second blue. You want both the balls to be blue. The first blue as well as second blue. Okay. Now, what is the probability of first blue? That is same 4 by 10 because, okay, originally bag has 4 blue and 6 black balls. Okay. 4 blue and 6 black balls, so 4 out of 10. But now it is without replacement. It is without replacement. So you take the first ball, okay, it turns out to be blue and you don't replace it back. You don't replace it back. So first ball is in your pocket now. First ball is in your pocket now. Okay, so when you are writing this probability, na? Okay, when you are writing this probability, there are 4 blue and 6 black in the bag. But when you're going to write down the next probability, so see, already the first ball is blue and you don't replace back, so it is in your pocket. So how many blues are there in the bag? 3 blues are there, 6 blacks are still there, but total also 9. Total 9. In the first case, there was total of 10. And hence, what is the second probability? This should be equal to 3 out of. This should be equal to, again, second blue, na? Second blue means favorable by total. How many blues are only left? Only 3 blues favorable, total 9. Okay, and then we multiply because of this AND or intersection condition. This is the probability of first blue, this is the probability of second blue. And hence the answer in this case is 4, 3, 12 divided by 90. Okay, or we can cancel by 6, so it is 2 by 15. That is how it is. Clear, everybody? 1 by 1 without replacement. This is the difference. 1 by 1 with replacement and without replacement. Okay, so whenever we are solving with replacement, probability of first blue or second blue or third blue, each of them will remain to be same, because whatever ball you draw, you replace it back to the bag. So bag goes to the initial position, and that is why probability every time is same. But here in the second case, when you don't replace, so one of that drawn balls, the first which was blue, it is in your pocket, and hence the contents of the bag will change, and that is why probability will change. Simple logic. Okay, done. Now third case is 2 at a time. So how do we solve this 2 at a time? Okay, third case is the case when you draw the balls not 1 by 1. 1 by 1 is over. You draw 2 at a time. Okay, and you want probability both blue. You want the probability that both should be blue. You want the probability that both should be blue. Okay. Now, that means this time you have not drawn 1 by 1. You just put your hand once in the bag, you draw 2 balls together and you want both to be blue. How many ways it is possible? Again, we will use a simple idea. The simple idea is favorable by total. Okay, favorable by total. Now, what is favorable here? What is total here? See, let's break the language. What is total here? Total means, okay, total number of ways means number of ways to draw or number of ways to select any 2 balls out of 10. How many balls are there in the bag? 10. Okay, because I do it single time, I don't do it 1 by 1. I put my hand inside the bag, I draw 2 balls. Okay, that 2 balls can be anything, maybe both blue, maybe both black, maybe 1 blue, 1 black, anything can happen. Na? So when I say total means sample space. So what are the 2 balls? It may be both blue or both black or 1 blue, 1 black. That is the list of everything that can happen. So in how many ways you can select any 2 balls out of 10? Maybe the 2 balls are blue or maybe black or anything, any 2 balls out of 10. But what is favorable? Favorable is the event whose probability is required. So what is the probability required? Probability required is both blue. Okay, so in favorable, you only want that both the balls selected are blue. Okay, so in how many ways you can select 2 blue balls, only blue balls, that is the favorable. Okay, 2 blue balls, and out of blue balls can selected only from blue only. Na? Blue balls can only be selected from blue balls, and there are total 4 blue balls. Okay, so this is what, this blue ball is my favorable condition actually. Okay, so now dear, when coming to this situation, drawing the items 2 at a time or 3 at a time, so here ultimately you have to use combinations, correct? Number of ways. So in general, before I write down this answer, okay, in general, whenever you have this context, number of ways number of ways of selecting, okay, k items or k elements out of n is given by nck. That is what is given by the combinational formula, selection formula. Number of ways of selecting any k items out of n is given by nck, and where nck is given by the formula factorial n upon factorial k, factorial n minus k. Okay, factorial n minus k. Okay, before I write down any, before I come back to the question, let me just write down important points. The formula is already noted, but on the other hand, always remember NC0, okay, yeah, NCK more generally. See, this is a, this is something that we can discuss separately in the PNC, permutation and combination, but some basic points are required that I will tell you. NCK is equal to NCn minus k. Okay, also at the same time, okay, NC0, of course, will be NCn, both of them will be 1. You can check by the formula also. And NC1, okay, will be equal to NCn minus 1, and that will be equal to n. Okay, and whenever you are solving NCK, basically, okay, rather than formula, what is the technique you should apply? Okay, rather than using the formula, NCK, you should start solving n minus 1, n minus 2, etc., etc. Okay, so numerator, okay, start from n and in the decreasing form, n minus 1, n minus 2, etc. How many terms? Total k terms. Okay, total k terms divided by 1 into 2 into 3. So denominator start with 1 in the increasing form up to again up to k terms. So 1, 2, 3, etc. up to k. Okay, let's put it this way. Okay, the suppose if I want to write down what is 8c3. So one of the ways formula 8 factorial upon 3 factorial into 8 minus 3 factorial. Or what is the direct way of solving it? Okay, you should always be quick in calculation. So 8c3 will be equal to how much? I told you numerator will start with 8, denominator will start with 1. Denominator increasing, how many terms? Up to 3, up to k, 8 to 1 into 2 into 3. Numerator decreasing, how many terms? Okay, 3 terms, so 8, 7, 6, total 3 terms, not up to 3, total 3 terms, so 8, 7, 6. So 2, 3 cancelled with 6, then the answer is 56. Okay, similarly, suppose if I need, what is the value of, suppose 11, C, 8. Okay, so this looks like bigger calculation, 8 terms will be there. So better 11C8 is also 11C3. That is what I told you, NCK is NCn minus k. So you can use 11C3 and then that is again equal to how much? Denominator starting with 1 up to 3, 1, 2, 3. Numerator starting with 11, decreasing order 3 terms. So 11, 10, 9. 11, 10, 9. So this is 5. Okay, this is cancelled with 3. Okay, so 55 into 365. Okay, just check the calculation once. Okay, yeah, correct. So these are some simple calculations about NCK that I want to revise in front of you. Just 1 or 2 minutes spent here. Okay, so number of ways of selecting any 2 balls out of 4. Selecting 2 out of 4, 4C2. Number of ways of selecting any 2 balls out of 10. Selecting 2 items out of 10 is the 10C2 formula. Now let me write down the calculation. 4C2, 4 into 3 upon 1 into 2. Okay, numerator 4, decreasing order 2 terms, denominator starting with 1 up to 2. Similarly, 10C2, okay, numerator starting with 10, decreasing form only 2 terms, so 10 and 9. Denominator starting with 1, only 2 terms, so 1 into 2. So see, 1 into 2, 1 into 2 is cancelled. Your answer is 4 into 3 divided by 10 into 9. Your answer is 12 divided by 90. Your answer is same as case number 2. Okay, case number 2 means 1 by 1 without replacement. And not only this, guys, always remember 1 by 1 without replacement or all at a time will always be equivalent case only. Okay, what is the different cases? 1 by 1 with replacement, that will always come as a different answer. But 1 by 1 without replacement or 2 at a time, 3 at a time, all at a time, they will always produce the same answer. They will always produce the same answer. Okay. Without replacement. And next is 2 at a time, or maybe 3 items at a time, depends on the question, all at a time. These 2 will always produce same answer. So you can use any one. Okay, These two will always produce the same answer. Okay. Now, similar to balls, okay, similar ball question only, bag and ball, another question. Just some data change, some context change, another question here. Please take up this question and do answer in front of me quickly. Yeah. A bag contains 5 white and 9 red balls. 3 balls are drawn from the bag. What is the probability that exactly 1 ball is white? What is the probability that at least 1 ball is white? So again, that language also coming up, exactly 1 or at least 1, that we have seen in the beginning questions. Okay, a bag contains 5 white and 9 red. Okay, that is total 14. Okay, 3 balls are drawn. Acha, how? Are they telling 1 by 1? No, of course, let me take 3 at a time. Of course, 3 balls are drawn, so of course it means together. Okay, if they were drawing 3 balls 1 by 1, so they will mention 1 by 1 what pattern, with replacement, without replacement. So it is 3 at a time. Okay, 3 balls means 3 balls, of course, at a time. Of course, at a time. What is the probability that exactly 1 ball is white? What is the probability that exactly 1 ball is white? And what is the probability that at least 1 ball is white? See, let's solve both of them. Okay. What is the probability that exactly 1 ball is white? Okay, that means 1 white and 2 red, which means what? Okay, it means 1 white but 2 red. Red nahi. Ha, correct. The other one is red. 1 white and 2 red. You want exactly 1 to be white, na? So 1 white and 2 red. Okay. Now, what is the probability? See. Favorable by total. How many balls are selected? 3 balls are selected. And how many balls are available total? 14. So what are the total number of cases? 14C3. 14C3 means select any 3 balls out of 14. Whether one is white, whether all are white, whether all are red, whether 2 white, 1 red, anything can happen. Total means anything can happen, any 3 balls. Okay, all 3 can be white, all 3 can be red, 1 white, 2 red, 2 white, 1 red, anything can happen here. Clear? Okay. Numerator, that is your favorable condition, and this is the favorable condition, 1 white and 2 red. What do you want? 1 white and 2 red. Okay, so in how many ways you can select 1 white out of 5? 5C1. And of course this 1 white comma 2 red means what? This is 1 white and 2 red. Okay, so 1 white out of 5, 5C1, and 2 red out of 9, 9C2. And means multiply again. Okay, the 5C1 into 9C2. Is it the answer? Yes, exactly 1 white, so 2 red. This is how it is, 5C1, 9C2. Okay, 5C1 into 9C2. Okay, so let me expand this calculation. 5C1 will anyways be 5. 9C2, 9 into 8 by 1 into 2 divided by 14C3. So 14 into 13 into 12. 3 terms. Okay, divided by 1 into 2 into 3. 1 into 2 into 3. This is what it is. Okay, so let's see the final answer then. Yeah, let's see the final answer. So 1 into 2 cancelled, 3 going above. Okay, so let me just calculate and write down the final answer in front of you. Just a moment. Okay, and any doubt in the concept? No, 1 ball is white means we can also take 2 white, 1 red, or 3 white also, Venkat. No. That is coming in the next case, Venkat, when at least 1 ball. First question is exactly 1 ball white, exactly 1, not less than 1, not more than 1. Clear, Venkat? Not less than 1, not more than 1. What you are telling can come in the next case, maybe 2 white, at least 1 white means at least 2 white also. Okay, 3 white also, there or anything can be possible. 1 white or 2 white or 3 white, that is in the next case. Okay, so yeah, let me multiply the numbers and write down the result in front of you. And 3 also will be shifted there. So this is 1080. Divided by 14 into 13 into 12. 2184. So I think simplified form can be 135. I'm dividing by 8. I'm trying dividing by 8. And this is 273. Okay. I think further divisible by 3, 91. So final answer, if I want to write, it should be 45 by 91. That is a simplification that you can do later also. Okay, now coming to the second one, dear. What is the second? What is the probability that at least one ball is white? What is the probability that at least one ball is white? Okay, so at least one white means it can be one white or, okay, acha, one white, then two red, okay, or two white, one red, or three white. Okay, that is what all possibilities here. Now, at least one ball is white. Okay, so maybe one or more than one. So one white, two red. If two white, then one red, or maybe all three white. So there is no red ball. There is no red ball. That is how it is. Clear? That is how it is. Okay, so now here maybe you look like you have to solve three cases. Maybe it looks like you have to solve three cases. But better, what will I do? Okay, these becomes three different cases. What will I do? Rather than solving three different probabilities, what is the simple thing I can do? I can here apply probability of at least one event. Probability of at least one white is equal to 1 minus probability of none. That means 1 minus probability of no white. Acha, no white means all red. No white means all three are red. Okay, now denominator is still 14C3. Okay, any 3 out of 14. Now what is the favorable condition? 3 red balls. What is the probability of 3 red balls? Okay, so total 9 red balls, out of which in how many ways you can draw 3 red? So 9C3. Selecting any 3 red out of 9, 9C3. So this is the probability of selecting 3 red balls. That means no white ball. And 1 minus none will give you at least 1. So this comes to a simple calculation. This will be a single calculation. Otherwise you have to solve 3 different probability. Although if you solve 3 probabilities and add, the answer will be same as this one. The answer will be eventually same as this one. So how much is this going to turn up? Okay, let me just keep checking it. So that is going to be 504 divided by 2184. Okay, solving which 1680. Yeah, so this time it looks like 70 by 91 should be the last answer. Or we can further here again divide by, in that case, 7 also. Okay, so this is 10 by 13. This is 10 by 13. So whatever, simplifications can be dealt later. I hope your intent of the question is clear to you. The language of the question and the solution is clear to you. So here what is the approach I have taken? Probability of at least one ball is simple 1 minus probability of none. That's what I explained in the beginning. That is a simple result but useful here. Okay, because if I use this, only one calculation. If I don't use it, so 3 calculation, because at least one means 1 white or maybe 2 white or maybe 3 white. So more number of calculations are there when I am going to solve at least one. More number of calculations are there. Correct? Next question. Okay, hope this is also clear to you. Chalo, let's move ahead to the next question. A box contains, again a counting based question, 6 positive numbers, 8 negative numbers, and 4 numbers are drawn at random. Of course, together. Of course, it means together only at a time. 4 numbers are drawn at random and multiplied. What is the probability that their product is a positive number? Okay, total 6 positive and 8 negative. That means 14 total. And you want the product to be a positive number. You want the product to be a positive number. How the product can be a positive number? How the product can be a positive number? Simple. Case number 1, all 4 positive. Case number 1, all 4 positive. All 4 positive. Okay. Case number 2, okay. Option number 2, okay. 2 positive, okay, but 2 negative. Because negative into negative will definitely be positive. So if you take 2 negative and multiply, they are multiplied together, the result will be positive. But if you take a single negative number, okay, plus into plus into plus into minus, 4 numbers are multiplied, 3 are plus, suppose, plus plus plus, 4th is minus. Plus 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 into minus, answer will be minus. But if two negative numbers come together in pair, so minus into minus will become a plus. Correct? That negative into negative will become positive. That is why, so I told you, if not all four positive, maybe two positive but two negative. Similarly, then there comes a one more chance. Okay, like two more negative. Okay, two pairs, one pair of negative numbers multiplied will produce a positive number. Okay, so here the next possibility can be two more negative. That makes all four negative actually. Okay, all four negative. That is also one of the valid case. Okay, chalo. So now, what are the probabilities? Okay, what are the probabilities? Yeah, in how many ways you can select four positive number out of 6? All four positive. Four positive numbers out of 6. Okay, then two positive, two negative. So two positive out of 6 and two negative numbers out of 8. Okay, and means multiply. Two positive and two negative. Both you want. Third case, all four negative. In how many ways you can select four negative numbers out of how many? There are 8 negative numbers. So in how many ways you can select four negative numbers out of 8? 8C4. That is 8C4. Okay. So now what is the answer? The required probability is always taken as the total favorable outcomes, okay, upon total possible outcomes. And favorable outcomes, okay, this is also favorable, this is favorable, this is favorable. Your favorable condition is product should be positive. And for the product to be positive, maybe all four positive, maybe all four negative, or maybe two positive, two negative. These are all favorable. Okay, so how many total favorable cases? Sum of all them. Sum of all of them. 6C4. Okay, 6C2, 8C2 and 8C2. 8C4, last case. Divided by total. Total means what? Total means out of the 14 numbers, select any four number, their product may be positive or negative. Okay, product equal to positive is only numerator, favorable condition. But total means you can select any four number, maybe one negative, three positive. Maybe the product is negative. Total means anything can happen. Any four numbers out of total 14. In how many ways you can select any four numbers out of 14 is 14C4. Okay, you solve it up guys, calculations up to you. This will be somewhere around 505 upon 1001, something like that answer will be there. Approximately I am telling you. Somewhere like this answer will be there. 505 by 1001, something of this sort. Okay. So calculations, you can handle. Okay, but the main thing is getting the language. Any confusions, please let me know. Okay. So, understanding what your favorable event is. What is the favorable event? Whose probability is required? I require the probability product is positive number. So, this becomes favorable for me. The product is positive number. This is what is. Okay. Now, how many favorable cases? How many favorable cases? Okay. All four positive. Of course, the product will be positive. Okay. But if negative comes, it should be in quantity of 2. Because a single negative number. Okay, because if there is a single negative number multiplied by other positive number will make the whole result negative, but I want the result positive. So if there is a negative number, it should be 2 or 4. Okay, so these are the three cases. There is no negative number, or two negative number, or maybe two more, so 4 negative number. Okay, so this is the list of all favorable outcomes. So I have added them. Okay, and total means any four numbers, maybe all four positive, all four negative, 2 positive, 3 positive, 3 negative, anything can happen here. Anything means anything. Okay, the total means what? Anything, sample space. Okay, list of all possibilities that can happen. So any four numbers out of 14 can be drawn. That is what is the total condition means. Chalo, another question. Simple one only. A college cricket team with 11 player. Okay, 11 player consists of 4 batsmen. Okay, 3 all-rounder, 3 bowlers and 1 wicket keeper. Okay, now 3 players are selected randomly. Find the probability that the selection contains a batsman, a bowler and an all-rounder. The selection contains what? A batsman and a bowler and all-rounder. Simple. How many players are selected? 3 are selected at random. Okay, again apply favorable by total. Finish it in one line. Again apply favorable by total. Finish it in one line. Okay, total means what? Total means out of 11 I can select any 3 players. Out of 11, I can select any 3 players. Maybe all 3 are batsmen, or all 3 are bowlers, or all 3 are all-rounder. Anything can happen. But favorable is what you require. What you require? That is mentioned in the question. So you require that selection should contain a batsman, a bowler, and all-rounder. One batsman, one bowler, one all-rounder. Okay, so in how many ways you can select a batsman? Out of how many? 4. So 4C1. In how many ways you can select a bowler? A bowler means single bowler. Out of 3 bowlers. In how many ways you can select an all-rounder? Single all-rounder. Out of 3. So this is 3C1. Okay, so 4C1 is 4, 3C1 is 3, 3C1 is again 3, divided by 11C3, so 11 into 10 into 9, further divided by 1 into 2 into 3. Okay, so this should be, this 3 goes above, but 3, 3, 9 cancelled. Okay, here I've cancelled, so 4 3s are 12, and this 2 adjusted here, 11 5s are 55. So 12 by 55, and yes, here we have the option also, option number C, 12 by 55. The final correct answer is 12 by 55. Okay, dear. So this is another variety. So a selection based, counting based question we have taken. Okay, now as I already mentioned to you, okay, Wednesday will be our next class, 9 p.m. Okay, but before I leave, let me just, give you a simple password. Okay, whatever we learn today, don't worry, your task is to focus and solve questions in your notebook. But rest all the proper solutions, and if there is any derivation, if there is any theory, it will be included in the PDF which I am sharing to you in my Telegram group. All that PDF will be password protected, because those who watch the session, they need the PDF. It should not be required by other students. That is a simple reason. And the password for the PDF will be select, SELECT, everything in small. Okay, this is going to be the password of the PDF. Please note down everything in small, SELECT, select. Randomly, we are solving some selection based question, so randomly crafted password. The PDF will be in my Telegram group. Okay, you can download the PDF, that will ask for a password, select. The simple idea, again I repeat, those who watch, those who are learning, they need the notes, otherwise there is no need of random notes. Okay, so please note down this password. Wednesday 9 p.m. we are going to meet next, as I told you, and we'll talk about dice, cards, and other miscellaneous questions. We'll keep learning more variety of questions, because learning and mastering probability means handling different variety of questions. That's what the objective is. Okay guys, so now very important update, the GENCO examination. Yes, also one more update about GENCO. So the Telangana state, the TS GENCO exam, the exam date is announced. Okay, the exam date for Telangana GENCO is 14th July. It has been announced just few days back, and the OM Institute brings to you the free online test series. Okay, for EE, there are 2 full mocks, full mock 1 and full mock 2, that is on June 23rd, coming Sunday, and then July 7th, and the test will be active at 1 p.m. Already, huge response is coming up to this one. Students have, registered already. A lot of students register. You can also take part in this free online test series. You can directly scan here if you want to go for the free registration of the mock test series. You can open the QR code scanner of your mobile and directly scan this code, or you can also contact 95156940053. Also, with respect to GENCO, let me give you another update. Tomorrow 6 p.m. Please note, if you are one of the students planning to appear in GENCO, okay, tomorrow at 6 p.m. okay, we have a practice session on control systems. I will be taking that. Okay, control systems question practice session. Important questions to be discussed. Control system question practice session. Control system question. You can search by my name, Sandeep. Okay. Conquer GATE ESE with Rakesh Sir. You can search by that name. Okay. So yes guys, tomorrow 6 p.m. on the same YouTube channel, OM Institute, you can join me for control system question practice session, specifically with the GENCO and other, state exams also. It will be helpful if, other state examinations also you are preparing for. Okay, GENCO, Transco, everywhere, that will be helpful. Alright guys, and for GATE 2025 for EC as well as EE, the next offline regular batch, yes, come and start practicing and studying under our expert guidance live at Hyderabad Center. Okay, and the next offline batch starts June 26. Okay, the fee, which is 66,000, has currently been put to 56,000, so you can take the benefit of it. You can contact 95156940053 for any queries. Okay, and also there are scholarships, like there are 50% scholarship for IIT and IT students, 50% for previous old students, 30% for triple ITs and state government university students. So there are scholarships. You can take the advantage of these scholarships as well. With this, I, Rakesh Sir, signing off. See you tomorrow 6 p.m. for the Genco practice session of control system, and again Wednesday 9 p.m. for the probability part number 2. Bye bye. Thank you. Good night. Stay safe and take care of yourself.